Good morning, all of you. So, we were discussing the basicity of amines, and in that, we have seen that the higher the pK values of the base, stronger is the base. So, here in the primary amines, we have seen a sequence that is the methylamine, ethylamine, and cyclohexane amines are the primary amines, and the pK values of these amines are written here. Then, in the secondary amines, the pK values are changing from 10.7 to 11.1 to 11. And then in tertiary amines, that is the trimethylamine, that is CH3 thrice N. Trimethylamine is having the pK value 9.6. Therefore, the triethylamine, that is CH3 CH2 thrice N, is having the pK value 10.8, and that of pyridine, that is the aromatic heterocyclic compound, is having the pK value 5.3. And so if we compare all these pK values of the primary, secondary and tertiary amines, the basicity of amine is given as the basicity of amines is given as secondary amines are more stronger than primary amines. Primary amines are more stronger than tertiary amines. And so this is the order of the basicity of between the primary, secondary and the tertiary amines. Then the aromatic bases, that is aniline, nitroaniline, that is the molecule with NH2 and the nitro group at para position, that is the paranitroaniline, aniline and paranitroaniline. Here the aromatic bases are weaker bases as compared to the aliphatic bases, because the lone pair of electron available with the nitrogen of amino group is involved in the delocalization in the aromatic ring. And so here we are getting the different resonating structures, and so the lone pair of electron which must be available for the donation is not available for donation. It's involved in the delocalization of the ring. So in this way, here we are getting the different resonating structures, and the lone pair of electron is not available for donation, and that's why they are weaker bases. And here in this way we are getting the different resonating structures, and the lone pair of electron is not available for delocalization. Then this will go and you will get the original structure. Same is the case in the paranitroanilines. Here this lone pair of electron is involved in the delocalization. Here this electron pair is shifted here, and here in this way we are getting a delocalization, that is NH2 plus, here double bond, N, O minus and O minus. So in this way, this delocalization of non-bonding electron pair, delocalization of non-bonding electron pair in the ring is possible, and that's why aromatic bases are weaker bases. So in this way we have seen the properties of the amines. Now we will turn towards the next part, that is the preparations of amines. And so for first, from alkyl halides. from alkyl halides. Now, the here from alkyl halides, that is the reaction of alkyl halide alkyl halide with ammonia with ammonia. So here, when the amines are amines can be prepared by heating the alkyl halides with alcoholic ammonia in a sealed tube, and a mixture of primary, secondary, tertiary amines along with the quaternary salt is obtained in this reaction. And so here this amine which is formed in the reaction immediately reacts with the hydrogen iodide, and which is produced in the reaction mixture gives the mixture of salts. And so here how the reaction proceeds, that we will see in the different step. So here the primary amine, that is the CH3 NH2 primary amine, sorry, here instead of primary amine we are allowing the ammonia to react with methyl iodide. And so here this gives the electron pair to this, and this CH3I bond breaks and gives you the formation of methyl amine methyl amine plus hydrogen iodide, which here reacts, this amine reacts with the hydrogen iodide which is formed in the reaction. This is your amine methyl amine. Here it's your methyl iodide methyl iodide and ammonia. And so when this reacts with the hydrogen iodide, it forms the salt, that is CH3 NH3 plus I minus, that is methyl ammonium iodide methyl ammonium iodide. So in this way, the primary amine which is formed in the reaction immediately forms the methyl ammonium iodide. Then this methyl amine, that is your CH3NH2 methyl amine, it reacts with the another molecule of methyl iodide, that is alkyl halide, and gives you the formation of methyl iodide methyl iodide and gives you the formation of secondary amine, that is CH3N CH3H, that is the dimethyl amine dimethyl amine. And dimethyl amine which is formed, it immediately reacts with the hydrogen iodide in the reaction and forms the salt of the secondary amine, that is CH3N CH3 NHH plus and I minus, that is dimethyl ammonium iodide, that is dimethyl ammonium iodide, means here the salt is formed. Then in the third step, the the dimethyl amine the dimethyl amine reacts with the third molecule of the methyl iodide, and you get the formation of trimethyl trimethyl amine trimethyl amine. And this trimethyl amine further reacts with the hydrogen iodide and forms the quaternary salt, that is CH3 NCH3 CH3 NH plus and I minus, that is the trimethyl trimethyl ammonium iodide. It forms the trimethyl ammonium iodide. And then further, the trimethylamine reacts with the fourth molecule of the methyl iodide and gives you the formation of the quaternary salt. Quaternary salt. And here you will get the formation of the quaternary salt, that is the tetramethyl ammonium iodide. It's also called as your tetramethyl ammonium iodide. So here we are getting the formation of a quaternary salt. Such type of reaction is less important for the preparation in the laboratory synthesis. Laboratory synthesis, it's less important, but because the separation of the product is difficult in the laboratory. But in industrial scale, this method is popular, which is used to prepare the all different types of amines, that is the primary, secondary and tertiary amines, because once this mixture is obtained, this is put up for the fractional distillation, and in the fractional distillation, the columns, these different fractions are collected in the different columns, and so at last the quaternary salt is remaining behind. So the next method, reactions of alkyl halides with reactions of alkyl halide with primary amine with primary amine, means the second step that we have seen in this, that is the methylamine, that is CH3NH2. This methylamine reacts with the alkyl halide, that is methyl iodide, and here you get the formation of the